Satyendra Nath Bose Fellow of the Royal Society, Bengali, Satyendra Bose, IPA, Atendranath Bal. The 1st of January 1894 to the 4th of February 1974, was an Indian physicist specializing in mathematical physics. He was born in Calcutta. He is best known for his work on quantum mechanics in the early 1920s, providing the foundation for Bose-Einstein statistics and the theory of the Bose-Einstein condensate. A Fellow of the Royal Society, the Government of India awarded him India's second highest civilian award, the Padma Vibhushan, in 1954. The class of particles that obey Bose-Einstein statistics, bosons, was named after him by Paul Dirac. A self-taught scholar and a polyglot, he had a wide range of interests in varied fields including physics, mathematics, chemistry, biology, mineralogy, philosophy, arts, literature, and music. He served on many research and development committees in independent India. Early life. Bose was born in Calcutta, British India, now Kolkata, West Bengal, India, the eldest of 7 children. He was the only son, with 6 sisters after him. His ancestral home was in village Berajagalia, in the district of Nadia, about 48 kilometers from Calcutta. His schooling began at the age of 5, near his home. When his family moved to Gobigan, he was admitted to the New Indian School. In the final year of school, he was admitted to the Hindu school. He passed his entrance examination, matriculation, in 1909, and stood 5th in the order of merit. He next joined the intermediate science course at the Presidency College, Calcutta, where he was taught by illustrious teachers as Jagadish Chandra Bose and Prafulla Chandra Ray. Meghnad Saha came from Dhaka, and joined the same college 2 years later. P.C. Mahalanobis and Sisakuma Mitra were a few years senior to them. Satyendra Nath Bose chose mixed, applied, mathematics for his BSc, and passed the examinations standing first in 1913, and again stood first in the MSc Mixed Mathematics exam in 1915. It is said that his marks in the Master of Science examination created a new record in the annals of the University of Calcutta, which is yet to be surpassed. After completing his Master of Science, Bose joined the University of Calcutta as a research scholar in 1916, and started his studies in the theory of relativity. It was an exciting era in the history of scientific progress. Quantum theory had just appeared on the horizon and important results had started pouring in. His father, Surendranath Bose, worked in the engineering department of the East Indian Railway Company. Satyendra Nath Bose married Ashabati at the age of 20. They had 9 children. 2 of them died in their early childhood. When he died in 1974, he left behind his wife, 2 sons, and 5 daughters. As a polyglot, he was well versed in several languages such as Bengali, English, French, German and Sanskrit, as well as poetry of Lord Tennyson, Rabindranath Tagore and Kalidasa. He could also play the esraj, a musical instrument similar to a violin. He was actively involved in running night schools that came to be known as the Working Men's Institute. Research career. Bose attended Hindu school in Calcutta, and later attended Presidency College, also in Calcutta, earning the highest marks at each institution, while fellow student Meghnad Saha came second. He came in contact with teachers such as Jagadish Chandra Bose and Prafulla Chandra Ray, who provided inspiration to aim high in life. From 1916 to 1921, he was a lecturer in the physics department of the University of Calcutta. Along with Saha, Bose prepared the first book in English, based on German and French translations of original papers on Einstein's special and general relativity in 1919. In 1921, he joined as reader of the Department of Physics of the then recently founded University of Dhaka, now in Bangladesh, by the then Vice-Chancellor of University of Calcutta Sir Ashutosh Mukherjee, himself a distinguished mathematician, a High Court judge, and with strong interest in physics. Bose set up whole new departments, including laboratories, to teach advanced courses for MSc and BSc honors, and taught thermodynamics as well as James Clerk Maxwell's theory of electromagnetism. Satyendra Nath Bose, along with Saha, presented several papers in theoretical physics and pure mathematics from 1918 onwards. In 1924, while working as a reader at the physics department of the University of Dhaka, Bose wrote a paper deriving Planck's quantum radiation law without any reference to classical physics, by using a novel way of counting states with identical particles. This paper was seminal in creating the very important field of quantum statistics. Though not accepted at once for publication, he sent the article directly to Albert Einstein in Germany. Einstein, recognizing the importance of the paper, translated it into German himself, and submitted it on Bose's behalf to the prestigious Zeitschrift für Physik. As a result of this recognition, Bose was able to work for 2 years in European X-ray and crystallography laboratories, during which he worked with Louis de Broglie, Marie Curie, and Einstein. After his stay in Europe, Bose returned to Dhaka in 1926. He was made head of the Department of Physics. He continued guiding and teaching at Dhaka University. Bose designed equipments himself for X-ray crystallography laboratory. He set up laboratories and libraries to make the department a center of research in X-ray spectroscopy, X-ray diffraction, magnetic properties of matter, optical spectroscopy, wireless, and unified field theories. He also published an equation of state for real gases with Meghnad Saha. He was also the Dean of the Faculty of Science at Dhaka University until 1945. When the partition of India became imminent, he returned to Calcutta to take up the prestigious Khera chair, and taught at University of Calcutta until 1956. He insisted every student to design his own equipment using local materials and local technicians. He was made Professor Emeritus on his retirement. He then became Vice-Chancellor of Visva University in Shantiniketan. He returned to the University of Calcutta to continue research in nuclear physics and complete earlier works in organic chemistry. In subsequent years, he worked in applied research such as extraction of helium and hot springs of Bakreshwar. Apart from physics, he did some research in biotechnology and literature, Bengali, English. He made deep studies in chemistry, geology, zoology, anthropology, engineering and other sciences. Being a Bengali, he devoted a lot of time to promoting Bengali as a teaching language, translating scientific papers into it, and promoting the development of the region. Bose-Einstein statistics. Possible outcomes of flipping 2 coins, 2 heads, 2 tails, 1 of each. There are 3 outcomes. What is the probability of producing 2 heads? Outcome probabilities: coin 1 head, tail, coin 2 head, HH height, tail, THDT. Since the coins are distinct, there are 2 outcomes which produce a head and a tail. The probability of 2 heads is 1/4. While presenting a lecture at the University of Dhaka on the theory of radiation and the ultraviolet catastrophe, Bose intended to show his students that the contemporary theory was inadequate because it predicted results not in accordance with experimental results. In the process of describing this discrepancy, Bose for the first time took the position that the Maxwell-Boltzmann distribution would not be true for microscopic particles where fluctuations due to Heisenberg's uncertainty principle will be significant. Thus he stressed the probability of finding particles in the phase space, each state having volume h3, and discarding the distinct position and momentum of the particles. Bose adapted this lecture into a short article, called Planck's Law and the Hypothesis of Light Quanta, and sent it to Albert Einstein with the following letter. Respected Sir, I have ventured to send you the accompanying article for your perusal and opinion. I am anxious to know what you think of it. You will see that I have tried to deduce the coefficient 82/C3 in Planck's law independent of classical electrodynamics, only assuming that the ultimate elementary region in the phase space has the content H3. I do not know sufficient German to translate the paper. If you think the paper worth publication, I shall be grateful if you arrange for its publication in Zeitschrift für Physik. Though a complete stranger to you, I do not feel any hesitation in making such a request. Because we are all your pupils, though profiting only by your teachings through your writings. I do not know whether you still remember that somebody from Calcutta asked your permission to translate your papers on relativity in English. You acceded to the request. The book has since been published. I was the one who translated your paper on generalized relativity. Einstein agreed with him, translated Bose's paper Planck's Law and Hypothesis of Light Quanta into German, and had it published in Zeitschrift für Physik under Bose's name, in 1924. The reason Bose's interpretation produced accurate results was that, since photons are indistinguishable from each other, one cannot treat any 2 photons having equal energy as being 2 distinct identifiable photons. By analogy, if in an alternate universe ions were to behave like photons and other bosons, the probability of producing two heads would indeed be 1/3, tail head equals head tail. Bose's interpretation is now called Bose-Einstein statistics. This result derived by Bose laid the foundation of quantum statistics, as acknowledged by Einstein and Dirac. Velocity distribution data of the gas of rubidium atoms, confirming the discovery of a new phase of matter, the Bose-Einstein condensate. Left, just before the appearance of a Bose-Einstein condensate. Center, just after the appearance of the condensate. Right, after further evaporation, leaving a sample of nearly pure condensate. Einstein adopted the idea, and extended it to atoms. This led to the prediction of the existence of phenomena which became known as Bose-Einstein condensate, a dense collection of bosons, which are particles with integer spin, named after Bose, which was demonstrated to exist by experiment in 1995. Although several Nobel Prizes were awarded for research related to the concepts of the boson, Bose-Einstein statistics and Bose-Einstein condensate, the latest being the 2001 Nobel Prize in Physics given for advancing the theory of Bose-Einstein condensates. Bose himself was not awarded the Nobel Prize. In his book The Scientific Age, physicist J. Nalyukar observed, S. N. Bose's work on particle statistics, c. 1922, which clarified the behavior of photons, the particles of light in an enclosure, and opened the door to new ideas on statistics of microsystems that obey the rules of quantum theory, was one of the top 10 achievements of 20th century Indian science, and could be considered in the Nobel Prize class. However, when asked about the omission, Bose himself said, "I have got all the recognition I deserve." Honours. In 1937, Rabindranath Tagore dedicated his only book on science, Visva Parichay, to Satyendra Nath Bose. Bose was honoured with title Padma Vibhushan by the Indian government in 1954. In 1959, he was appointed as the National Professor, the highest honour in the country for a scholar, a position he held for 15 years. In 1986, the S. N. Bose National Centre for Basic Sciences was established by an Act of Parliament, Government of India, in Salt Lake, Calcutta. Bose became an advisor to then newly formed Council of Scientific and Industrial Research. He was the President of Indian Physical Society and the National Institute of Science. He was elected General President of the Indian Science Congress. He was the Vice President, and then the President of Indian Statistical Institute. In 1958, he became a Fellow of the Royal Society. He was nominated as member of Rajya Sabha. Parthagos has stated that later works. Bose's ideas were well received in the world of physics, and he was granted leave from the University of Dhaka to travel to Europe in 1924. He spent a year in France, where he worked with Marie Curie, and met several other well-known scientists. He then spent another year abroad, working with Einstein in Berlin. Upon his return to Dhaka, he was made a professor in 1926. He did not have a doctorate, and so ordinarily he would not be qualified for the post, but Einstein recommended him. His work ranged from X-ray crystallography to grand unified theories. Together with Meghnad Saha, he published an equation of state for real gases. In addition to physics, he did some research in biochemistry and literature, Bengali, English. He studied other sciences, chemistry, geology, zoology, anthropology and engineering in depth. Being of Bengali origin, he devoted time to promoting Bengali as a teaching language, translating scientific papers into it, and promoting the development of the region,